So in this video, we'll discuss about the extreme value theorem and the mean value theorem. We'll do proofs of theorem related to it only. Now, the extreme value theorem states that if a function is continuous in a closed bounded interval, so this is a closed and a bounded interval, then f attains both a maximum value and a minimum value in the closed interval. So if we have a function like this, then the minimum value would be at point A, and the value of would be f of A. The maximum value would be at point B, and the maximum value would be f of B. But if we have a function like this, the straight line, then the minimum value equals the maximum, which is equals to a constant c. Okay, now related to this theorem is, let f be defined in an interval I and let c be an interior point of I. So we know, suppose c belongs to the open interval, which is the endpoints are a and b. So if c is a maximum or a minimum point of f, and if f dash c exists, then f dash c equals to 0. So what they are trying to say is that c belongs to an interval, and if c is it's an interior point, and if c is an maxima or a minimum value, then f dash c should be equals to 0. We need to prove this. So now suppose we take a case when c is a maximum. Suppose this is a function. At point c, the value is the maximum. Now suppose we take h very close to 0. So it would lie just to the right of c. And since at c the value is maximum, which is f of c, so f of c plus h would be less than f of c. So what we can see is, so what we have is f of c plus h minus f of c should be less than 0. And if we divide it by h, we get the slope only, or the Newton's coefficient. So what we have is f of c plus h, this image, minus f of c, which is the maximum image, by h should be less than 0. Now, because h is very close to, as h approaches 0 plus, because h is very close to 0 from the positive side, so this value would be close to f of c less than 0 for h close to 0 from the positive side. Okay, now similarly from the left hand side, c minus h, we can see f of c minus f of c minus h upon c minus h, as h approaches from 0 negative. So this is f of c minus f of c minus h upon c minus c plus h. So this cancels out. And since f of c is the maximum value, this would be greater than this. So this is greater than 0. So to the point very close to the left of c, what we have is f dash c is greater than 0. Now, since below this point, I will mark this in red. Since below this point, very close to c, f dash c is greater than 0. So the slope must be increasing. And beyond c, f dash c is less than 0. So the intermediate value theorem would state at point c, f dash c should be equals to 0. I hope this is clear. Now we'll move on to the mean value theorem. So what this mean value theorem states is that if f is a continuous function in the closed boundary interval a to b and differentiable in the open interval a to b, then there exists at least one interior point epsilon in the open interval such that f dash epsilon give you this value, which means, so suppose if we have a function like this, then from a to b, so if we join a line, the interval is from a to b, and then the theorem states that there would exist a point, at least one point epsilon, for which the slope of this line joining these 2 points and the slope of the tangent should be equal. That is, f dash e epsilon should be equals to f of b minus f of a upon b minus a. Okay, now if you want to prove this, suppose we define a function gx equals to fx minus f of a minus alpha times x minus a, where alpha equals to f of b minus f of a upon b minus a. Now since we have assumed that fx was a continuous function, so gx is a linear combination of fx only, so gx would also be a continuous function. Similarly, since fx was a differentiable function in the open interval a to b, gx would also be a differentiable function in the open interval a to b. Now we can find the value of g of a. G of a would be f of a minus f of a minus alpha times a minus a. We can substitute the value of alpha as well, but this a minus a would be 0 and this would cancel out. So 0 times alpha would be 0. So g of a is coming out to be 0. Now similarly, we can find the value of g of b. G of b would be f of b minus f of a minus alpha. Alpha is this term minus f of b minus f of a upon b minus a into b minus a. So b minus a cancels out. F of b would cancel out. So everything cancels out. So we are having g of b equals to a. Now since the function g is continuous in the interval a to b, g of x is continuous in a to b and differentiable in the open interval a to b. So with the help of extreme value theorem that we have already discussed in the above case, there would exist a maximum and a minimum value of this function in the interval a to b. So this was what we concluded from the extreme value theorem, right? If the function is continuous and differentiable, continuous in the closed bounded interval and differentiable in the open interval, then there would exist a maximum value and a minimum value of that function. Now suppose we say the maximum value occurs at point x star and the minimum value occurs at point x subscript asterisk. Okay, now we know g of a is coming out to be 0, g of b is coming out to be 0. So the minimum value should be less than equal to 0 and the maximum value should be greater than equal to 0. I hope this is clear, because 0, the value of 0 we are sure we will be getting. So if we are talking about the maximum value, it should be greater than or equal to 0. And if we are talking about the minimum value, it should be less than or equal to 0. Now suppose we consider the first case where the maximum value is greater than 0. Then x star cannot be equal to a because g of a is 0. And similarly, x star cannot be equal to b because g of b is 0 as well. So x star would lie between a and b. And similarly, we would have g dash x star equals to 0 because it is a maximum value, and we have seen in this proof as well, if c is a maximum value, f dash c is 0. Okay, so g dash x is coming out to be 0. So we have got a value of x star which belongs to the interval a and b. So this is the value of x star which belongs to this interval and for which we have the maximum value at this point. Okay, now suppose we are talking about m less than 0. So the minimum value m is less than 0 which occurs at x under subscript. Then x star cannot be equals to a because g of x star in that case would be 0, but we know the minimum value is strictly less than 0. Similarly, x subscript cannot be equal to b. So g x star which cannot be, so this cannot take place. So we know x star belongs to the interval a and b. Similarly, g dash x star would be equals to 0. Third case, when m, the maximum value equals to minimum value equals to 0, when we have a function like this. So suppose this is a, this is f of a, which is equals to f of b. But now since it is equals to 0 only, it would lie on the x-axis. So this is the interval and the image m equals to 0. Now in this particular case, this would be satisfied for any value of x in this. And since it is an open interval, so g dash x would be 0 for all x belongings to a comma b. So what we have seen is, in all the three cases, irrespective whether we are talking about a maxima or a minima, or both of them are equal to 0, we get a point x in the interval a comma b such that f dash x equals to f of b minus f of a upon b minus a. I hope this was clear. Thank you.